number 2. So for exam number 2, we need to focus on chapter 1, section 1.3. We discussed the triangle as far as the points are concerned. So what formula do we need to know as far as finding out the legs or the hypotenuse of the triangle?
Pythagorean theorem.
Wonderful. Thank you so much. That would be a squared b squared and equals to c squared. And remember, if you have a triangle, there's two sides that form the 90-degree angle right here. That those are your legs. The longest side, that would be your hypotenuse. So this here is your hypotenuse, and these are your legs, right? That's a leg. This is a leg, right? This is your hypotenuse. And this is a leg. This is a leg. All right. So we went over this last time, so I'm not going over this now because there is a recording for this. So this is section 1.3 for Pythagoras theorem. And this should be page 45, right? Did I write the page number? This is page 45. Okay. Chapter 1, section 1.3. And all of these topics are on exam number 2. When is exam number 2?
Tomorrow.
Yep, there you go. So chapter 2, section 2.1, focus on pages, I would say 102, 112, 122. This is all from the book, right? Um, oh, for 1.1, it would be 102. Just erase this. So chapter 2, 2.1, pages 102. And this talks about points. And in order for us to have a point, it would be an x value and a y value. And whenever we have 2 points, that's going to form a line, right? And if it forms a line, then we could have different types of lines. We could have an increasing line, a decreasing line. We could have a vertical line, a horizontal line. And in this case, we have an increasing line. We have 2.00 and 2.2. And if we plug those into the formula for the slope, which is right here, this is going to give me 2 over 1, which will give me rise over 1, which is 1 over 1. And when I plug it into the equation, I am going to get a linear equation of y is equal to 1 over 1x plus b. And this would give me the equation for this line. Now, what do you think the y-intercept is if you look at this line? What is that point that touches the y-axis? So this is the y-axis. So it's positive y, and this is negative y, and this is negative x, and that's positive x. What do you think is this value that touches the y-intercept?
Sure, almost.
Yeah, good. Very good. Yes, so this is my y-intercept. Very good. So if that's my y-intercept, and I know that the linear equation is this, y is equal to 1 over 1x plus b, and the linear equation is y is equal to mx plus b, and this is my slope, right? And my slope is 1 over 1, then b, we already said is 0, right? So my equation will be 1 over 1x plus 0. Because it's 0, we don't have to write 0. We could just write 1 over 1x, or we could just write y is equal to x. Because right here next to that x is a 1, right? So either all of these work. All right. And in this example here, right here, we have 2.06 and 1.2. All right, 0.6 and 1.2, or was it 0.6 or 1.2? No, it was 0. What were the 2 points? Right here. It was 1 comma 4 and 2 comma 2, and we needed to find the slope. So we use the slope formula. We plug in the values for x2, y2. Remember, you're always going to use the x value that is largest. So the x value that is largest here is going to be 2. So we're going to use that point first. So this is why we end up with a 2 here, and we end up with a 2 there. This represents y, this represents x, right? And then we subtract that from those values from x1 and y1, and we get a slope that is -2/1. That means that is going down, right? This is a negative slope. This is a negative slope. So I write my linear equation. I get y is equal to -2x plus b. I need to find my y-intercept. So in order for me to do that, I have to pick one of those 2 points, 1, 4 or 2, 2. And I plug it in. I chose 1, 4 because both are positive. And then here I solve for my y-intercept, and I end up with a y-intercept of 6. All right. Now, if I needed to find my x-intercept, if I need to find an x-intercept, what must be equal to 0? Well, it has to be y, right? So here in this case, I have to replace my y with 0. When I do that, I have to solve for x. I subtract -6 from both sides, and I end up with a -2x, right? Divided by a -2. And then here, I get a -6 divided by a -2. I get x is equal to 3. My x-intercept is 3, 0. The reason why I'm going fast is because we already did this, and it's already recorded. And if we go to the graph, we have here, this is our x-intercept. This is our y-intercept. Right? We already found these. And these were the 2 points that were given to us. And we have a purple line. And it shows that the line is going down. So for tomorrow's exam, you'll be expected to do all of this that I'm doing right now. And not only will you have to do a problem like that, but you'll also have to identify a graph. So in this case, you're given a graph and you are asked, what are the x-intercepts, right? So this is an x-intercept, right? Because it's touching the x-axis. This is another x-intercept because it's touching the x-axis. And this is another x-intercept because it's touching the x-axis. But this value here on top, that's touching the y-axis, this is a y-intercept. Okay? So both the graph or the equation, you're both responsible to do. All right, let's take a look. Okay, cool. And then we have this example here where x over -4 is equal to -7. And this is a negative parentheses -2. What's happening here with this equal sign? Is this the same as the previous example we did in exam 1? Or what do we do when we have an equal sign, guys? What do we do when we have an equal sign? Nope. All right. So when we have an equal sign, well, this is a proportion, so we have to do cross multiplication. So when you do cross multiplication, we're going to multiply the -4 times the -5 and x times 1. This is it right here. And we end up with x is equal to +20, right? And that's my final answer. And then I said, okay, what are you going to review in chapter 2? Well, you're going to review 2.1, 2.2, 2.3, 2.5, 2.7. These are the page numbers. So all of these, right? And all of these are equations, right? And then for chapter 3, you have to review functions. That's section 3.1, 3.2, page 201 and 227. So we kept going. And that was everything we did that day. Up until that, from the topics, because that day we had touched on topics from exam 1. And then I said, moving forward here, all of this is exam 2. And we were getting pretty late, and we only ended up here. And then I said, oh, in summary, don't forget that this is what you need to focus on, right? So on the next day, right, I said, okay, let's talk about everything that you need to touch on. So chapter 1, page 45. That's Pythagoras theorem, right? And we did finding the x and the y intercepts the day before. We did a linear equation. We did a linear equation using two points. We did that. And then on this day, on this particular day, we did the rectangle, right? We did quadratic formula. We didn't have to do quadratic formula in exam one, but in this one, you're going to have to do quadratic formula. And we did linear inequalities on this day. And we also introduced functions, right? And we said, you got to name that function, right? You got to name that equation, right? This is an equation, right? And I said the sections was 3.1, page 201, 3.2, page 227, and we talked about domain and range. And this was yesterday, 6 p.m. exam, 80 minutes in person, 10 questions. And it's the same thing for tomorrow. Tomorrow's going to be 10 questions, 80 minutes. And you see how I operate. I start at 6, I finish at 7:20. So you want to get there as soon as possible. This is not a surprise to anybody that we're having an exam. You've been hearing about this from the day that you registered for this class. All right, and today is Thursday, and we are having class via Zoom. Tomorrow is Friday, 6 p.m., room 1C03, 10 questions, 8 minutes
Um,
each. Go ahead.
quick question. So how do we know if we passed or failed the first exam?
Oh yeah, we'll talk about that towards the end of class today.
Oh, okay.
Yeah,
Thank
most
you.
definitely. Yeah, I don't want to be the bearer of bad news at the beginning, and then people are not focusing on the math. Because we're all emotional, right? We're all humans, and if we hear bad news, or well, if it's good news, it's great. But if it's bad news, then that's just gonna really mess us up when it comes to focusing on the math. So I'd rather leave that for last. But thank you for asking. All right, so then we got into inequalities, and then we had this example of x is greater than 1, and we talked about that when it doesn't have an equal sign, it's not included. And what that means is that we have an open circle. And when we have an open circle, the value of 1 is not included, but it has to be recognized that it exists, right? And this is going to positive infinity. Now, in the second example here, x is greater than or equal to 1. What's happening here is that I have an equal sign. So that means this is solid, right? This is all solid. And then this is going to go all the way to positive infinity. All right. So now how would we write that in interval notation? And that's when I introduced interval notation. And I said, if you have a bracket, that means it's included, right? There is an equal sign. So there is an equal sign. But when you're writing parentheses, there is no equal sign. All right. So then we gave another example. So in this case, do we have a solid? Yes. So that means we have an equal sign. So this is 3, right? The values of x are less than or equal to 3. So anything up until 3, including 3, is part of the solution. So to write that in interval notation, this is how I would write it. Either one of these is valid, right? Then we talked about interval notation for a line segment. This is called a line segment. You don't have to know the name, but I'm just letting you know what it is. And that a line segment is a line that has 2 points. They could be solid or they could be open, but there are 2 points. So it doesn't go to negative infinity, it doesn't go to positive infinity. So in this case, since they're both solid, I have 2 brackets, and it's going to go from -3 to +3, right? And this is what this comma means, right? After that, we went into inequalities. And these inequalities, we have to solve for them, and we have to make sure that we understand the rules of inequalities. If we divide by a negative, then what that means is my sign is going to change. What is the sign that I'm talking about? This sign right here. So if I divide by a negative, then that sign flips. So the rule is, and I wrote it here, the first step is to move all x's to the left. So I did that. I added 2x, I added 2x. So on the right side, it disappears, it goes to the left, and I end up with what did I end up with? Well, I have a -4x and a positive 2x. I ended up with -2x. Then I have a -5. And in order to get rid of it, I had to add a 5, right? So I added 5 to both sides. On the left side, the 5 disappeared. So now I have negative 2x is greater than what? Greater than 4. So what's happening here? Well, I have to divide by a negative. What did I say earlier? If you divide by a negative, what happens to the sign? The sign flips, right? So you see how it flips? So now it's x is less than negative 2, right? So if I have to do this in a number line, well, I have an open circle because I don't have an equal sign here. And the sign is pointing to the left, so this is why it's going to the left. Then it's go to negative infinity. So how would I write that? How would I write that as an interval notation? Well, the negative 2 doesn't have an equal sign, so this is why I have a parentheses here. And it's going to go to negative infinity to the left, so that's also going to be a parentheses because we don't know where infinity ends. So that's the answer. All right, so let's continue. Then I discussed about factoring and using the quadratic formula. I said, oh, there are 2 ways of doing this problem. You could factor and then get 2 terms, and from those 2 terms, then that would be great. Then you have your answer. Or you have to use the quadratic formula if you can't factor, right? So if you can't factor, you got to use what? This is the quadratic formula right here. And the quadratic formula says x is equal to negative b positive minus square root of b squared minus 4ac over 2a. You don't have to memorize this formula, but I will give it to you. I'll put it on the board tomorrow. So I have to identify the a, the b, and the c. And then I gave the example of Sesame Street. So this is my a. This is why that's 1. This is my b. That's a negative 1. There you go. And then c is a negative 6, right? So that's good. I plug and play. I put all of these values into the equation. I solve for it. And I end up with the same answer, right? And that's what I said. So what was the point of using the quadratic formula? Well, in this case, I wanted to prove to you that if you could factor something, you don't want to use the quadratic formula. But if you're told to do the quadratic formula or you cannot factor, then you have to do it, right? So this is where this problem comes in, right? Where we put x squared plus 3x minus 5. We found our c value, our b value, our a value. We plug it in. And after we plug it in, we get our square roots. Now, since you have calculators, and I was very happy that the majority of you brought your own calculator. That's good. Make sure tomorrow you bring pencils and erasers. As you already know, I don't have any pencils or I don't have any erasers. So it's very important that you invest in yourself so that way you can succeed. So now if you have the calculator, you're able to convert the radical sign. Which radical sign? The square root of 29. You both have a positive and a negative, and you end up with 5.39 here, negative 5.39 here. When you do the math, your final answer would be x is equal to 1.19, and excuse me, x is equal to negative 4.2. Now, do you have to go with a decimal? No, you could have stopped right here. You could do full stop here. All right, so you're not obligated to give me decimals. Now remember, there are no graphing calculators allowed. So this is why some of your calculators that you brought in, I had to switch them over to scientific. All right, section 2.3, page 137. That's our next topic that we touched on 2 days ago, and this was the rectangle. So how many lengths does a rectangle have?
2.
2.
Yeah, very good. And it has 2 widths. So when you add them together, you have 1 length, 2 lengths, one width, 1 width. So you end up with 2 lengths and you end up with 2 widths. Now that's not the hard part, right? Because that's perimeter. The hard part is interpreting the word problem. So in this case, I give you an example, and I said, the length of a rectangle is 5 less than triple the width. So I circle this for a reason, because here you have the length. The length of a rectangle. So we know it's a rectangle. So the length is, right? The length is, so that's an equal sign. 5 less, so that's negative 5, then triple the width, right? So the way we write that is right here. This is 5 less than triple the width. What is that equal to? Well, it's equal to the length. And I know what my formula is, right? My formula is this. My formula is perimeter is equal to 2 times the length and 2 times the width. If I know the length is 3w minus 5, then I'm going to replace L with 3w minus 5 times 2. Where did I get this 62 from? Well, if we go back and look at the question or the statement, it says the perimeter is 62. Find the dimensions. So I replace P with 62. And now I have to distribute this 2 to the 3w. I have to distribute to the negative 5. And I'm going to end up with what? I'm going to end up with 6w minus 10. And I have my 2w on the right. Do I have common terms? Yes, I do. I have 6w and 2w. They become what? AW. The negative 10 comes down. And what is the goal? Well, the goal is to find w, right? Which is the width. So I add 10 to both sides, and I get 72 is equal to 8w. 8w gets divided by 8 in order to find w for both sides, and my width is 9. So what does that all mean? Well, earlier I said length is equal to 3w minus 5. So if length is equal to that, well, what am I going to put for w? I'm going to put a 9 here, right? Minus 5. So this is what? This is 27 minus 5. This is 22. So my length is 22, while my w is equal to what? 9. What are they looking for? What do they say? What is the width? What is the length? All right, so you got to practice problems like this. All right, let's keep going. Then we introduced chapter 3. We gave an analogy of being in a relationship and why it's very important to be faithful. And functions are the same way. You cannot cheat with your ex, especially when you're doing a vertical line test. And that is the definition of a function, right? In a relationship that is working and it's functional, then you're not cheating with your ex. That means your x values are not being touched twice. In this example here, your x values are being touched twice. So because of that, that is not a function. And we saw that where? Points 1, 2, and 1, 3, right? Is the x value the same? And the answer is yes. If the x values are the same, this is not a function. Then after we spoke about that, we looked into what is a linear equation. Well, the moment we change this this y to f of x, it becomes a function. Does that mean that the y disappears? No, it's just a different way of writing it, right? And now the f of x is telling the world that you are not a cheater, you are a function, right? That you will pass the vertical line test every time. Then I went into explaining what f of x is. So I said, f parentheses parentheses is the value of y. The x value that's inside, that goes inside, right? This x value goes inside. That x value is your input. I wrote it right here. And your y value is the output. So when you have an x value, which is your input, let's say it's 1, you plug it into the equation, and you get another value. As a result, that output is your y value. So that's exactly what we did. So if we say f1, we are saying replace x with 1, and that's exactly what we did. 2 times 1 is 2 plus 3 is 5. So y is 5. So when my x is 1, what is my y? Well, my y is 5. It doesn't get any more simpler than that. So just practice doing that. So now, in this example, I said f of x is equal to 2x plus 3, and I said graph it. So in this case, the 3 is my y-intercept, so that's why I wrote 0, 3. I have a slope of 2, so I go up 2 here, and I run 1. All right, I go up 2, and then I run 1. Up 2, then I run 1 value. And that's how I get my next point, which is 1, 5. All right, and this is another example of exactly what we did earlier in order to find all these different values. And what value did we find here? Well, this is my x-intercept. How do I know that? Because all x-intercepts, their y values are 0. Look at it. The y value is 0. Now, for a y-intercept, their x value is 0. So it's the opposite, right? And then we went into, okay, well, we've been talking about linear equations and we have a degree of 1. Well, what happens when we have a linear, not a linear equation, but we have an equation that has a degree of 2? Well, I said, well, that has a special name, and that's called a quadratic. And that also has another name. These mean the same thing. Quadratic and parabola. And I said to you, we're going to go to the zoo and we're going to learn about the horse, the zebra, the donkey, and the pony. They're all animals. And because they're all animals, it's the same thing as saying linear function, parabola, cubic, square root, right? They're all functions. Just because they're all functions doesn't mean they look the same and they don't have the same equations. So for our first example was the linear function. That's f of x is equal to mx plus b. And you have to know the name and you have to know the equation for the exam tomorrow. If you don't remember this, you're going to get this wrong. Quadratic function and parabola, that is the name. This is the equation. You have to know this. What is the name? Cubic function for this. What is the equation? F of x is equal to x to the third. What is the name? The name is square root. What is the equation? F of x is equal to square root of x. Just like if I say to somebody, what's your name? Grant. You know, you're going to say, well, my last name is Grant. Just like you know your last name, you better know this. Because if you don't, you're going to get it wrong. Absolute value function, this is the name. And this is the equation. All right, what is the name for this? Well, this is the name, cubic root function. And this is the equation. What about this one? Well, this is the odd reciprocal function. This is the name. This is the equation. So what is the name of this? Well, this is an even reciprocal function. That's the name. And this is the equation. So what is the difference between this equation and that equation? Well, this has a degree of 1, right? This is a degree of 1, while this one has a degree of 2. There's a big difference. And you see how they're graphed differently, right? The one that's in the odd function is in quadrant 1, right? This is quadrant 2 and quadrant 3, and this is quadrant 4. So in which quadrant is the odd one? Well, it's going to be in quadrant 1 and quadrant 3. In what quadrant is the even one? Whoa, too many. The even one is in quadrant 1 and in 2. All right, so you got to remember those specific characteristics. Then from there, we moved on to domain and range. Now, what is so cool about domain and range? Well, the cool thing about domain and range is domain is like the train. It goes from the left, it goes to the right. It does not go up and it does not go down. Domain is all x values, while range is the y values. That goes up, that goes down, like the elevator, right? And then we talked about how to read domain for this particular examples. So here in this parabola, we said, well, where is this going to the left? Well, this is going to negative infinity. Where is it going to the right? It's going to positive infinity, right? That is domain, and that is how I got that. This is domain. Well, how'd you get range? Well, range is the lowest value with the highest value. So the lowest value here would be the vertex. This is called the vertex. This is the lowest point in this parabola. And since we're talking about range, we're dealing with the y value. So the y value has a value of 0. And where is it going? It's going up. Where? Do you know where it stops? No, it's going to positive infinity. So this is the range for this quadratic equation, which is called a parabola. So now that brings us to the square root. Since we have the square root begins at 0, 0. So the domain would be bracket 0 because that's a solid circle and it's going to go to positive infinity. What about the range? Well, the range is talking about the y values, right? Right here. These are the y values. 0. And where is it going to? Well, I see that the arrow is going to the right, but the arrow is not only going to the right, it's also going up, right? It's also going up. Because if I wanted to redraw this graph, right? If I wanted to redraw this graph is going like this. It's going to the right, but it's going up. You see? So it's going to the right, but it's also going up. The up is the range, and the right is the domain. Okay? And this is why the domain is 0 to the right for x values. And the range is 0 for y, going all the way up for y values. Okay? So then I said, well, how do you know if this is a function or not? Well, you got to pass it through the vertical line test. So you do vertical line test for all of them. Pop, 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 pop. If you pass and you hit the x value once, then it's a function. Then we talked about the following, and I gave you lots of examples for the circle, and I said, is this a function? And we came to the conclusion that it is not a function because that x value is being touched twice, such as like the arepa, the pancake, the cookie, the pupusa, the tortilla. All of these things that are circular, they are not functions, right? Because it cannot pass the vertical line test. Then we did an example of input output, and I said, okay, if I have the following problem, and I say f2, that means that the value of x is 2. How do I find my y value? Well, I got to replace the x with a 2, and I get a 7 as my output. So my y is a 7. Then I said, in the next example, I said, well, if f of x is equal to 7, what is x? So here I am saying that y is equal to 7. So if y is equal to 7, then I replace y with 7. And then now I have to solve for x. And guess what? I ended up with 2. Because I wanted you guys to see how you can go from the x value, which is here, to the y value. Or you could go from the y value, which is here, to the what? To the x value. And what was the x value here? It's 2. All right, so we did all of that, and that was the last thing we did. So now we could begin our class today. And all of this is being recorded, and the previous class was recorded too. So if I went too fast over here or I didn't go in detail, there was plenty of time to go and review the previous video. So now let's move on to the next topics on the exam 2 and also on the final. When is the final?
Monday?
No. No, the final's not Monday. Who saw the syllabus?
Tuesday.
Okay. So we have Zoom class on Monday, right? You guys saw that? Well, let's check. You know, this is why I put stuff online so we could go check them. So if we look at the syllabus, take this out of here and put it over here. And we're going to take a look at the slide. And you should all be seeing my screen. All right. So today is day 5. All right. We did a lot of this. We did inequalities. We've done functions. We've done linear. We've done quadratic. We've done, like, literally, we've done almost all of these, if not all of them. And then tomorrow is the exam, right? And then on Monday, we have class again via Zoom. And that's also going to be a review for the final. And then on Tuesday, we have our final. And it's done. Yippee! All right, let's keep going. Let's see. All right, cool. So I should be seeing my iPad. Wonderful. I'm so happy to see you guys yesterday. It was really cool. Finally get to see you because none of you turn on your camera. You're so shy and bashful. I feel like when you turn on your camera, you feel that connection as opposed to just, speaking to names. But it's cool. Um, okay, so let's talk about when we have an equation, right? When we have an equation and we have to find domain. Like all of these examples before, when it came to domain, we were like, okay, look at the graph. The graph is going to tell you, what the domain is, what the range is. But what happens when you're not given a graph? What happens if you're given an equation, right? So if you're given an equation like this, let's say, square root of x. If they ask for domain and range, we are going to look at, first, we need to change f of x to y, right? That's the first thing. Then the second thing I am going to say that you need to look at, oh, by the way, this is positive, negative, right? Is what is inside the radical sign for this problem, right? So let's just segregate this. What's inside the radical sign here?
X.
X.
Yep. So we want to make y equals to 0. So we're going to make this equal to 0. But we have the problem that this has a radical sign. So in order for us to get rid of the radical sign, right? What do you think we got to do? Take the square root. Not the square root. Take the square of it. So this and this cancel out. And what is 0 squared? Well, this is going to give me 0.
0.
So all of this is going to drop. And I'm going to end up with x is equal to 0. X is equal to 0 is the first x value for domain. Okay? Now, since I already taught you that square root of x, when you graph it, looks like this, then where is the direction going?
Positive.
It's going to the right, right? So another way of doing this, and I'm showing you different ways, is y, right? Y is equal to square root of x, right? But because this has a direction of going to the right, because of the graph, right? We see the graph. We're going to say square root of x is greater than or equal to 0. Why is that? Because where is this pointing to? To the right. Since it's pointing to the right, that matches the graph. And this is an equal sign because this is a solid point here. Okay? So now, in this example, we're not going to do all of this crazy math that we did over here. We're just going to drop the square root, and we're going to say x is greater than or equal to 0. So that means that my domain, if I write it in interval notation, is going to be what? It's going to be bracket 0 to positive infinity. And how do I know that? Because all x values, right? This is saying all x values are greater and equal to 0. So greater means to the right, not less than, right? So this is why, do we know where it stops? We don't know where it stops. So it's positive infinity. Since we don't know where it stops, it has to be a parentheses. We know the zero is a bracket. So this concept is very important. So now let's do another example. What happens if you have x is equal to, f of x is equal to the square root of x plus 1? Well, like I said before, you take this value here, right? You have two ways of doing this. I find the left is a little bit more complicated. So I take the square root, x plus 1 is greater than or equal to 0. I drop the square root, and this becomes x plus 1 is greater than or equal to 0. Subtract 1, x is equal to, well, not x is equal to because there's no equal sign there. There is a greater than or equal to sign, minus 1. So how do I write that in interval notation? Well, bracket, because there's an equal sign here. -1, where is this going? To positive infinity, right? How do I know it's going to the right? Because this is going to the right. This is going to the right. This is going to the right, correct? So this is my domain written as an interval notation. Now, how do we determine y? Well, I'm going to show you right now. F of x is equal to the square root of x. There is an imaginary value here. What value do you see there? Not an imaginary, an invisible, I should say. Not an imaginary, an invisible number. What do you think it is? It's invisible.
1?
It can't be 1 because if we put a 1 there, it changes the equation.
Oh.
What number will not change nothing?
0.
Yes, a 0. So there is a 0 here, a positive 0. This positive 0 is the value for my range. So you're like, what? I don't get it. Well, you see this right here? This is a y. These two are connected. So we're going to say y is equal to 0. Why do we say that? Well, because what controls domain? X values, right? And didn't we say earlier that the lowest x value here for this problem here, what's the lowest x value that we could have? 0. That's right, Peña. Very good. So if y is 0, and what's in blue here is my domain, and that is the value of x, and that is 0, then I have an initial point, right? X and y, right? My initial point here would be 0, and my initial point here for y would be 0. And how do I know I'm right? Well, because f of x is equal to the square root of x. If I draw this, starts at 0, 0, right? That's a 0, 0, right? That's an x and a y. And when I draw this, it's going to look to the right, correct? But remember, right is domain. What is range? Range is y values, right? So if this is a y value, this is going up. Do you see it going down to negative infinity? What is the lowest value for y? 0, right? So the same thing here. What is the lowest value that I can have for y? Well, if f of x is y, the lowest value I can have is 0 right here. So that would be my range. What would be my range? Well, my range is going to be bracket, right? This is for y values, right? Because range is y value. It would be bracket 0 to positive infinity. All right? Now, how do we do that for an equation? Let's say, well, I gave you an equation earlier, x plus 1, right? F of x is equal to the square root of x plus 1. So if they ask you for domain, we already did this, right? X squared plus 1 greater than or equal to 0. Then I drop the square root, right? -1, x is equal to -1. Well, not equal to. I keep making that mistake. Greater than, Professor. What are you doing, buddy? So this would be greater than, right? -1. So it's my domain, right? And this would be bracket -1 to positive infinity. And this is domain. Why? Because these are x values. But now you are being asked, what is the range? Well, the range is f of x is equal to the square root of x plus 1. What is outside the equation? What did we say?
0.
0. So since that is a 0 outside the equation, this is y is equal to 0. So this would mean that my value, knowing that my equation is going to the right, this is going to be bracket 0 to positive infinity. Now, some of you might say, well, how does he know that? Well, if I graph it, this is going to be here at -1, right? It says -1 here, right? -1. So if this is -1 and my range, my lowest value is 0, then this is -1, 0, right? Right? Because that's my x and that's my y. So where is this going? Well, this is going from -1, 0 to positive infinity. So my domain is -1 bracket to 0, and my range is 0 bracket to positive infinity. Range is y values. This is up and down. It's not going down. This graph is not going down. And my domain are x values, and that's left and right. All right, so let's keep going. All right. So we are coming down to the last two topics for this class. And I'm going to introduce them right now. Let's take a little break. So everything from here up is exam 2. Down is exam 3, which is the final. And the final includes exam 1, comma, exam 2, and the following topics. Are you guys ready? Are you guys ready? Wow. You guys are so quiet. All righty. Let's keep moving. Where is it? No, I don't see it. Sorry, guys. Taking so long. There it is. Okay. So I have the following two lines. I have, so this is systems. Is this going to be on tomorrow's exam? Yes, no? What did I say? Anything down is going to be for what?
Exam 3.
Right. So do not study this for tomorrow. This is for Tuesday. Systems of linear equations. This is section 7.1. All right. Now, a system means there are two things to make a system. When people get married, two people are getting married to create a system. That system is called marriage. Here, mathematically speaking, two things are interconnecting. So, since we're talking about lines, right? Linear is a line. Let's look at this. Y is equal to 3x minus 5. And x plus 3y is equal to 6. So you have those two lines. Is the line on the left, does that look like a line? Yes or no? Nobody knows if this looks like a line, the one on the left? Does it look like y is equal to mx plus b?
Yeah.
Yes.
Okay, good. So this is okay. Thank you. So now for the second line, yes or no? Does this look like a line?
No.
Does this look like mx plus
No.
b? No. Because it is a no, we have to make it look like a line. So we're going to take x plus 3y is equal to 6. We are going to subtract x. So this cancels out. And then this is 3y is equal to negative x plus 6. Now, it's looking similar to a line, but it's not there yet because what's happening with the y? Doesn't it have something attached to it? Doesn't it have that 3? So I have to divide by 3. So now I end up with y is equal to negative x over 3 plus, what's 6 divided by 3?
2.
2. Good. Now this here is the same thing as saying y is equal to negative 1 over 3 times x over 1, right? Because a 1 times x will give me, I'm sorry, a negative 1 times x will give me negative x, and a 3 times 1 will give me x, right? Plus 2, right? So now it looks like a line. So now I have two lines. So I bring this down, and I have y is equal to 3x minus 5. So now, how do I do this? Well, I need to make these two lines equal to each other. So that's exactly what I'm going to do. 3x minus 5 is equal to negative 1/3 x, right? That's tied together by marriage, right? Plus 2. Now, what did I say you have to do all the time when it comes to the x's? Do we keep them on the right or on the left? We got to move them to the left. So plus 1/3 x. So now this cancels out, plus 1/3 x, right? So now I have on the left, what do I have? 1/3 x plus 3x minus 5 is equal to positive 2. What am I going to do with this negative 5? I'm going to bring it over to the other side.
Add it to the 2.
There you go. I get a 7 here. And now I have 1/3 x plus 3x is equal to 7. How do I add this? Well, I got to have the same denominator, right? So I'm going to put a 3 here. and a 3 here. So then this is 3 over what? 3 over 9 x plus, what is this? 9x over, oh, no, sorry. Hold on. What am I doing?
Is 1.
It's a 1. I don't need to do that. One second. 3 times 1 is 3, 3, 3, plus, okay, no, I can't do that. Sorry, 1 second. I'm going backwards, 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 I tell you. There you go. There you go. So I have 1/3 x plus 3x. So what do you think? What do you think I got to do here? Mm, mm, mm. Nobody? 1/3 x plus 3x. This is 3 over 1. What is 1/3? Use a calculator. Sorry. Use a calculator. What is 1/3? 1 divided by 3. Well, this is going to become 0.3333 x plus 3x. Now, I just changed the fraction, right? So this is going to become 3.33x is equal to 7. So what do I got to do here? I got to divide by 3.33 divided by 3.33. And now this cancels out. X is equal to 7 divided by 3.33. And I get 2.10. Now, because I got a decimal, it doesn't look that good. I am going to take this x value, and I have two equations, right? I have y is equal to 3x minus 5, or I have y is equal to negative 1 over third x plus 2. So I can use either of these two. I'm going to go with the one that doesn't have a fraction. So I'm going to replace x with what? I'm going to go y is equal to 3 times something minus 5. What am I going to replace that with? What is the value of x?
2.9.
2.10. Good. So 3 times 2.10 is going to give me 6.30 minus 5. And this is going to give me 1.30. Y is equal to 1.30. So when my x is equal to 2.10, my y is equal to 1.30. This point here is the point that is the same for both equations. So how does that look like? Well, let's draw it. 1, 2, 1, 2. So 2.1 would be around here for x, right? But for y, it's 1.30, so it would be around here. So this point here is a special point. I'm going to put a circle. I'm going to draw the first graph. You're not responsible to graph it, but I just want to prove it to you. 1, 2, 3, 4, 5. That's my y-intercept. And I have a slope of what? 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Right there. Then I have another graph, which is +2. It's my y-intercept. And I have a slope of 1 down 3. 1 down 3. 1 run 3. 1, 1, 2, 3 would be around here. So I have one line going this way. This line is y is equal to -1/3 x plus 2. And then I have another line that goes like this. This point here is an intersection. This is what's creating my system. And this line here is y is equal to 3x minus 5. This is a positive line. This is a positive line because it has a slope of 3 over 1. And this is a negative line that has a slope of -1/3. Now, isn't that interesting? It's pretty cool. So these are systems of linear equations. Now, the next topic is area. So let's talk about area. One moment, guys. All right, cool. Take a look at this. How are you guys doing?
I'm good.
All right, good. I'm glad. I'm glad.
I'm sorry, I'm just at work. That's why I'm not like really talking that much.
No, it's all good. I understand. We all got our obligations, trust me. Generate. All right. So, what do we know about a rectangle? What do we know about a rectangle? Anybody? So we got a length, we got a length, we got a width, we got a width. Well, gives us perimeter, right? Because perimeter is equal to 2 lengths, right? Plus 2 widths, right? So we got that. So now when it comes to the area is a bit different, right? Area is length times width. So we have width times length, right? So when we do area, this is length times width. A is equal to L times W. Now, and for perimeter, when we were doing the example for perimeter, we are just measuring the fence, right? Everything in purple. That's the fence. But when we're doing area is everything inside. This is area. Okay? Now, if you're given a word problem, we have to understand that concept. The area of a rectangular garden is 240 square feet. All right. So when you multiply feet times feet, you get square feet. Okay. The length is 8 feet less than the width. What are the dimensions of the garden? So you need to have this in mind when you do a problem like this. So you do a rectangle. So this is your garden, right? That's what they're saying, right? A garden, a rectangular garden. The area inside is equal to 240 square feet, right? So you know the width is going to be feet, the length is going to be feet, and when you multiply feet times feet, you're going to get feet squared. So you know that much, right? Cool. All right. The length, so we already did sentence number one, right? We did one. The length, so they're referring to this right here, right? So L is 8 feet less than W. Right? This is the width. This is W. And it's 8 feet, what? 8 feet less than the width. So that's how we write it. And they want to know the dimensions, right? So they want to know length and they want to know what? Width. That's what they're asking for. So if we have that, well, what is the equation? What do we know about the equation? Well, the equation is area is equal to length times width. And they're saying that the length, which is right here, this is equal to what? W minus 8. This is times what? Times W, right? And what did they say the area is? What did they say the area was? What was the area? 200 square feet, right? But now, in order to do this problem to not complicate things, you're going to drop the square feet. So here, we're going to say, okay, 240 is equal to W minus 8, right? Times W. So can I distribute this W to the W and to the negative 8? Absolutely. So I'm going to get W squared minus 8W is equal to 240. All right, so far so good. Now I want to find W. So I need to find the value of W. So I'm going to subtract 240 from both sides. This cancels out. This becomes a 0. And this is W squared minus 8W minus 240. Now, what is the goal? The goal is to find what?
W.
Yeah, that's it. So let's look at this. What is the value of A? What is the value of B? Thank you. And what is the value of C? Well, A is equal to 1. B is equal to negative 8. C is equal to negative 240. So in this case, I have to use what? I have to use X is equal to negative B plus or minus the square root of B squared minus 4AC over 2A. Now, this X here, in reality, is what? This is W, right? Which is my width. So now, what am I going to do with the B? Well, I gotta replace all of these values, right? So this is negative box minus square root box squared minus 4 times box over 2 box. All right. So I have A is equal to 1, B is equal to negative 8, and C is equal to negative 240. So having said that, B is -8. Well, let me put it in blue. B is equal to -8. B is equal to -8. A is 1. And C is -240. And A is 1. All right, so I got it there. So now a negative and a negative is a +8. Plus or minus, this is 64. And then this is -4 times -240. I'm going to need my calculator. So 240 times 4 is going to give me a positive 960 because a negative and a negative is a positive over 2. So now, what is 960 plus 64? This is 1,024 over 2, positive, negative, +8. What is the square root of 1,024? Well, the square root of 1,024 is positive -32 over 2. And I have two answers here, right? I have +8 plus 32 over 2, and I have +8 minus 32 over 2. So this is going to become what? This is going to become 40 over 2, which is what? 20. And then this is going to become what? 32 minus 8, that's 24. So this is going to be -24 over 2, that's -12. Now, I have two answers. My first answer is +20 for width. And then my second answer is -12. Which of these two answers is valid? And explain why. Can you have a negative width? Can you say, oh, this is -10 inches? Do you say that? Or do you tell people, my baby right here is -24 inches?
No.
Mm-mm. Distance can never be negative. So, and also height. You can't have negative heights. So, my answer for my width is 20. So what am I going to do here? Well, if this is 20, then what is my length? Well, we said that the length is equal to W minus 8, right? So if my length is equal to 20, which is my width, minus 8, then what is my length? My length is 12, right? So my length is 12, my width is 20. Does that make sense? I don't know. Let's see. I take my rectangle, I got 20 here, and I got 12 here. If I take 20 times 12, right? Because this is what? This is my width times my length, right? Is going to give me my area. 2 times 0 is 0. 2 times 2 is 4. 1 times this is 0. This is 2. I get 240 square feet. Is that the area here? The answer is yes. So this is what you're going to be responsible for when it comes to the area. When is this going to happen? Are you going to see this tomorrow in tomorrow's exam?
No.
No, this is on Tuesday. So you have Saturday, Sunday, and Monday to practice this problem. Not only do you have Saturday and Sunday and Monday to practice this problem, you also have that same time to do this problem here. These are the only two topics that are new for the final because the final covers what? All of this. You see? All of this is on the final. Exam 1 and exam 2. All the topics. And the only new stuff that you are responsible to learn for the final is systems of linear equations and area. This is why I am how I am when it comes to focusing on the class. Because if we focus and we can do this, then we have enough time to study. Other professors teach this class and they're teaching these topics that I just taught, the area and the systems of linear equations, on Monday. Do you have enough time to practice if you just learn them on Monday and they're going to test you on Tuesday? No. So this is why I'm so strict when it comes to this. Okay, so it's 7:21. Um so let's take a look at the grading. Um I had I don't want to